This is part 2 of creating a critical path network from an activity table, video 2, where we're going to do a forward and backward scan on the network that we created in video 1. In video 1, the activity that we were drawing a network for was assembling and using a flat pack barbecue. This was the project table, the table of activities, and this was our network that we came up with. So you'll notice that in each of the I'm going to get rid of this extra node. Each of the nodes, there's a left-hand side and a right-hand side, and you'll also notice that the activities sit on the arcs. There is a method, I think, of doing critical path networks where the nodes actually represent the activities, but I don't know how to do that, so I'm not going to teach it. So what we're going to be doing is we're going to be working our way from the start to the finish of this network, and I'm just going to pause for a sec. So as you can see, I've prepared some numbers there to save you having to watch me type. Okay, so we're going to do a forward and a backward scan. The forward and backward scan allows us to see what activities lie on the critical path. The critical path is the sequence of tasks that have to be done exactly on time in order for our optimal finishing time for the entire activity tasks to go to happen. Really poor words, you'll forgive me. Okay, so we're going to go from start to finish. And we've noticed that the first node on the left-hand side, we can either go via A, which is 5 minutes long, or via B, which is 6 minutes long. Now this is where critical path networks are different to the networks that we've done before. We've always been obsessed with shortest path. Critical path network, we need the longest path. We need to actually do all of task B before we can go on to task C. It's no point just doing task A and going on with task C after we've done task A, because B needs to be done as well. So the number that's going to go on the left-hand side of that node is a 6, because that's the longest path from the beginning to that node. Then the longest path from this node to this node, well, there's only one way to go, and 6 plus 10 is 16. So 16 goes on the left-hand side there. 16, similarly, plus 5 is 21. 21 plus 10 is 31. We don't need to think too hard about that until we get different pathways. 31 plus 20 is 51. And now here's the first time that we've got to think. Second time we've got to think. To get to this node here, we can either go via F, 31 plus 3 is 34, or via G and H, 51 plus 2 is 53. And once again, we're looking for the longest path. So 53 is the winner there. 53 plus 15, we have to compare that to, 53 plus 15 is 68. We've got to compare that to 20. 68 wins hands down if we're looking for the largest. And then 68 plus 15, I think if I calculate it correctly, is 83. So the time it should take for us to put that flat pack barbecue in and also cook the food, prepare the food and cook the food, should be 83 minutes. Let's hope we're not too hungry. So now let's work backwards to do a backward scan. And once again, we're going to start from one end, but we're going to go backwards this time to get to the other end. This time we're going to subtract each time. 63 take 15 is 68. Clone, 68. 68 take 15 is 53. 53 take 2 is 51. 51 take 20 is 31. Now you could say 53 take 3 is 50, and I know that we've been saying we need the larger number, but when we're on our way back, it's actually the smaller number on the way back. So 51 take 20 is 31. It looks to me this is going to be a bit of a boring one where all the nodes are the same all the way. 31 take 10 is 21. 21 take 5 is 16. 16 take 10 is 6. And that's all there is to it. Now, I know you're probably thinking to yourself, well, that's pretty easy. All I've got to do is make sure both sides have the same number in them. That's not always the case. Let me see if I can find another one for you to look at. Oh, that looks like that's it there. That's our answer no, that's a boring one as well. Okay, here we go here. In this particular network, our critical path was this one along the bottom, and we had all of these other ones that were happening in the meantime. So when we were going backwards along this path, we had to go 15 take 1 is 14. 15 take 2 is 13. 15 take 1 is 14. 14 take 3 is 11. And all these nodes where the numbers are different on both sides, those are the ones where you have some slack time. We're going to talk about that in the next video. So let's have a look at this. We now have done a forward scan and a backward scan, and we're almost finished. We only need to talk about slack time, which we're going to do in the next video. Stay tuned.